Chapter 10 Straight Lines. The general equation of a straight line in two-dimensional geometry is a linear equation in two variables x and y. It will be of the form ax plus by plus c is equal to 0, where a and b are not 0 simultaneously. In this general equation, if the constant term c is 0, say, then the equation will be of the form ax plus by is equal to 0. In this case, the line passes through the origin. Let us now write the general equation of a line in slope-intercept form. The slope-intercept form is y is equal to mx plus c. The general equation is ax plus by plus c is equal to 0. Therefore, by is minus ax minus c divided by b minus a divided by bx minus c divided by b. By comparing this equation and this equation, slope m is equal to minus a by b and y-intercept small c is equal to minus c by b. Let us now reduce it to intercept form. The general equation is ax plus by plus c is equal to 0, and the intercept form is x divided by a plus y divided by b is equal to 1. Ax plus by is equal to minus c. We will divide the whole equation by minus c. We get minus a by c times x minus b by c times y is equal to 1. And which can be written as x divided by minus c divided by a plus y divided by minus c divided by b is equal to 1. Now, by comparing these two equations, x-intercept is minus c divided by a and the y-intercept b is minus c divided by b. Now we will reduce the general equation of a straight line to normal form. The normal form of a straight line is x cos omega plus y sin omega is equal to p. The general equation is ax plus by plus c is equal to 0. We will divide the whole equation by root of a square plus b square, where a is the coefficient of x and b is the coefficient of y. We get a divided by root of a square plus b square times x plus b divided by root of a square plus b square times y is equal to minus c divided by root of a square plus b square. We divide by root of a square plus b square so that a, b and root of a square plus b square, they form a Pythagorean triplet. So that if we take the ratio a by root of a square plus b square as cos omega, then b by root of a square plus b square will become sin omega. Now comparing the normal form and this equation, we get cos omega is equal to a divided by root of a square plus b square and sin omega is equal to b divided by root of a square plus b square and p, that is length of the normal, is equal to c divided by root of a square plus b square. It can be taken as minus c or plus c, but it should be a positive quantity because length of the normal is a distance. Therefore, this quantity should be kept as positive in the normal form. If it is negative, we have to change the sign of the whole equation. So, we have to select an appropriate sign for cos omega and sin omega so that P is a positive quantity. We will see the distance between two parallel lines formula. Let L1 be one given line and L2 be another line which is parallel to this. And we have to find the distance between two parallel lines. Distance between two parallel lines means the perpendicular distance between them. Let us draw the perpendicular from the origin to these two lines. Let this be P, this be Q, and we are going to find the distance PQ. Let the equation of line L1 be AX plus BY plus C1 is equal to 0, and equation of the parallel line be AX plus BY plus C2 is equal to 0. If two lines are parallel, only the constant terms will be different. The length of the normal formula is absolute value of C divided by root of A square plus B square. Normal is a line drawn from the origin perpendicular to the line. The length of the normal OP for L2 line is absolute value of C2 divided by root of A square plus B square, and length of the normal for line L1 OQ is absolute value of C1 divided by root of A square plus B square. Therefore, the distance between two parallel lines PQ is equal to absolute value of C1 minus C2 divided by root of A square plus B square. We have absolute value sign in the numerator, so we may write C1 minus C2 or C2 minus C1, does not matter. But before using the formula, make sure that the coefficients of A and B in these two parallel lines equations are same. Now we will see the formula to find the distance of a point from a line. Let the given line be AX plus BY plus C is equal to 0, and the given point is x1, y1. Let this be the given line L and P be the given point x1, y1. And we are going to find the distance between the point P and the line. Distance between point and a line means the perpendicular distance, which is the shortest distance. We are going to find the distance PQ. So to make our work easier, let us draw a line parallel to this given line L through the point P. We will take this as L2 and the given line as L1. Therefore, equation of L2 line will be AX plus BY plus C1 is equal to 0. If two lines are parallel, only constant terms will be different. Slopes are equal. And this P point x1, y1 lies on L2. Therefore, AX1 plus BY1 plus C1 is equal to 0. Therefore, C1 is minus AX1 minus BY1. Now, we will find the distance between these two parallel lines. Draw a perpendicular from the origin to these two lines. So, the distance RS will be equal to the distance PQ. The distance between two parallel lines RS and PQ are same, which is equal to, the formula is absolute value of C1 minus C divided by root of A square plus B square. Absolute value of minus AX1 minus BY1 minus C divided by root of A square plus B square. We can change the sign and write, because of absolute value sign it does not matter, divided by root of A square plus B square. This is the formula to find the distance of a point from a line. Let us do exercise 10.3. First question. Reduce the following equations into slope-intercept form and find their slopes and the y-intercepts. The slope-intercept form of a line is y is equal to mx plus c. First subdivision. The given equation is x plus 7y is equal to 0. Let us reduce it to slope-intercept form. 7y is minus x. Therefore, y is minus 1 divided by 7x plus 0. Let us compare this equation and this equation. Therefore, slope m is minus 1 divided by 7 and the y-intercept c is 0. Second subdivision. The given equation is 6x plus 3y minus 5 is equal to 0. Let us write it in slope-intercept form. 3y is minus 6x plus 5. Therefore, y is minus 2x plus 5 divided by 3. By comparing the equations, the slope m is minus 2 and the y-intercept c is 5 divided by 3. The third subdivision, the given equation is y is equal to 0. Already this equation is in slope-intercept form. By comparing the equations, the slope m is 0 and the y-intercept c is also 0. Second question, reduce the following equations into intercept form and find their intercepts on the axis. The intercept form of a line is x divided by a plus y divided by b is equal to 1, where a is the x-intercept and b is the y-intercept. First subdivision, the given equation is 3x plus 2y minus 12 is equal to 0. 3x plus 2y is equal to 12. We need 1 here. We will divide the whole equation by 12. X divided by 4 plus y divided by 6 is 1. So we changed it to intercept form. By comparing the equations, we can write the x-intercept a, which is 4, and y-intercept b is 6. Second subdivision, the given equation is 4x minus 3y equal to 6. We will get 1 here by dividing the equation by 6. 4x divided by 6 minus y divided by 2 is equal to 1, which can be written as x divided by 3 divided by 2 plus y divided by minus 2. We can say that the x-intercept a is 3 divided by 2 and the y-intercept b is minus 2. The third subdivision, equation is 3y plus 2 equal to 0. 3y is minus 2. We will divide the equation by minus 2. 3y divided by minus 2 is 1. Y divided by minus 2 by 3 is equal to 1. There is no x-intercept in this. A is 0 and y-intercept is minus 2 divided by 3. The given line is parallel to x-axis. That's why there is no x-intercept. Question 3. Reduce the following equations into normal form. Find their perpendicular distances from the origin and angle between perpendicular and the positive x-axis. The normal form of a line is x cos omega plus y sin omega is equal to p, where p is the length of the normal. and omega is the angle between the normal and the positive x-axis. First subdivision, the given equation is x minus root 3y plus 8 equal to 0. We will take the constant term to the other side. We will change the sign of the equation throughout so that the right hand side is a positive value. Now we will divide the equation by root of a square plus b square. Remember, to change the general form to normal form, you have to divide the whole equation by root of a square plus b square, which is root of a is the coefficient of x minus 1 the whole square plus b is the coefficient of y, which is root 3 square. Root of 4 is 2. We will divide the equation by 2. Minus half x plus root 3 divided by 2y is equal to 4. This is p value, which is length of the normal. Now comparing the equation which is in the normal form and this equation, we get cos omega as minus half, sin omega as root 3 divided by 2 and p value as 4 units. Cos is negative, sin is positive. It is second quadrant angle and the base angle is 60 degrees. Therefore, omega will be second quadrant angle pi minus the base angle, which is 2 pi divided by 3. Omega is 2 pi divided by 3. Now we will write the equation in the normal form. X cos 2 pi by 3 plus y sin 2 pi by 3 equal to p is 4. Second subdivision, the equation is y minus 2 equal to 0. Therefore, y is equal to 2. We have to divide by root of a square plus b square, which is root of 0 plus 1, which is 1. Therefore, the equation is already in the normal form. Cos omega is the coefficient of x, which is 0. Sin omega is the coefficient of y, which is 1. And p is the constant term. Remember, p has to be a positive quantity. P is 2 units. Cos omega is 0, sin omega is 1. Omega is pi by 2. Now we will write the equation in normal form. X cos pi by 2 plus y sin pi by 2 equal to 2. Third subdivision, the equation is x minus y equal to 4. We will divide by root of a square plus b square, which is root of 1 square plus minus 1 the whole square. Divide the whole equation by root 2. 1 divided by root 2x minus 1 divided by root 2y is equal to 4 divided by root 2. We can simplify 4 divided by root 2, it becomes 2 root 2. P has to be a positive quantity. It is already a positive number. P is 2 root 2. The coefficient of x is cos omega, which is 1 by root 2, and coefficient of y is sin omega, which is minus 1 by root 2. Cos is positive, sin is negative in the fourth quadrant, and the base angle is pi by 4. Therefore, omega is 2 pi minus pi by 4, which is 8 pi minus pi divided by 4, 7 pi by 4. Therefore, omega is 7 pi by 4. Now, let us write the equation in the normal form. X cos 7 pi by 4 plus y sin 7 pi by 4 is equal to P is 2 root 2. Question number 4. Find the distance of the point minus 1, 1 from the line 12 times x plus 6 is equal to 5 times y minus 2. Let us first simplify this equation. 12x plus 72 is equal to 5y minus 10. 12x minus 5y plus 72 plus 10 is plus 82 equal to 0. We know the formula to find the distance of a point from a line. The formula is absolute value of ax1 plus by1 plus c divided by root of a square plus b square. Substitute this point in the line equation. That is the numerator 12 times minus 1 minus 5 times 1 plus 82 under absolute value sign divided by root of a is the coefficient of x and b is the coefficient of y, minus 5 the whole square, which is 5 square. Absolute value of 82 minus 17 is 65 divided by the denominator 144 plus 25 is 169 and root of 169 is 13. 65 over 13 is 5 units. Question number 5. Find the points on the x-axis whose distances from the line x divided by 3 plus y divided by 4 equal to 1 are 4 units. The point is on the x-axis. So let the point be x1, 0. For all points on the x-axis, y coordinate will be 0. And we will use the distance formula. Distance of a point from a line. Absolute value of ax1 plus by1 plus c divided by root of a square plus b square. We will change this equation to general form. We will multiply the equation by 12. 4x plus 3y equal to 12. Therefore, 4x plus 3y minus 12 is equal to 0. Now, the distance d is given as 4 units and the numerator of this formula we get it by substituting this point in the line equation, which is 4x1 plus 3 times 0 is 0 minus 12 under absolute value sign divided by root of a is 4, 4 square is 16, b is 3, 3 square is 9. 16 plus 9 is 25, root 25 is 5. 4 times 5 is equal to absolute value of 4x1 minus 12. To remove the absolute value sign, we have to write plus or minus on any one side of the equation. Now we have two equations to solve. 4x1 minus 12 is equal to plus 20 and 4x1 minus 12 is equal to minus 20. 4x1 is 32. Therefore, x1 is 8. Here 4x1 is minus 20 plus 12 is minus 8. Therefore, x1 is minus 2. We have two answers. Therefore, the points are 8, 0 and minus 2, 0. Question 6. Find the distance between the parallel lines. 15x plus 8y minus 34 is equal to 0 and 15x plus 8y plus 31 is equal to 0. The distance between two parallel lines formula is absolute value of c1 minus c2 divided by root of a square plus b square. To use this formula, the coefficients of x and y in these two parallel lines should be the same. Here they are same. Therefore, absolute value of minus 34 minus 31 divided by root of a is 15 square plus b is 8 square, which is equal to 65 divided by 15 square is 225, 8 square is 64, 289. Root of 289 is 17. The distance is 65 over 17 units. The second subdivision, the equations are L times x plus y plus p equal to 0 and L times x plus y minus r is equal to 0. We will use the same formula. D is equal to absolute value of C1 from the first line equation is P minus C2 from the second line equation is minus R divided by square root of coefficient of x is L and coefficient of y is also L. So, L square plus L square. Absolute value of P plus R divided by root of 2L square. Square root of L square should be a positive number. We don't know whether the value of L is positive or negative. Therefore, we will write absolute value of L. Absolute value of P plus R divided by root 2 times absolute value of L. Or we may write the answer as 1 by root 2 times absolute value of P plus R divided by L. If the coefficients of x and y in these two parallel lines equations are not the same, either you multiply one of the equations or divide the other equations by some constant to make their coefficients same, and then use the distance between two parallel lines formula. Question number 7. Find the equation of the line parallel to the line 3x minus 4y plus 2 equal to 0 and passing through the point minus 2, 3. If two lines are parallel, only their constant terms will be different. So, we will write the equation of the parallel line as three x minus 4y plus c is equal to 0. Now, the point minus 2, 3 lies on this line. Let us substitute this point in the line equation. 3 times minus 2 minus 4 times 3 plus c is equal to 0. Minus 6 minus 12 plus c is 0. Therefore, c is 18. Now, we will write the equation of the line. The answer is 3x minus 4y plus 18 is equal to 0. Question 8. Find the equation of the line perpendicular to the line x minus 7y plus 5 equal to 0 and having x-intercept 3. Let us write the slope of this line. The formula is minus a divided by b. A is the coefficient of x and b is the coefficient of y, which is 1 by 7, from which we can find the slope of the perpendicular line. Therefore, slope of the perpendicular line is negative of its reciprocal using the formula m1 m2 is minus 1. Now, we know the slope, we know the x-intercept, we will use slope x-intercept form. Y is equal to m times x minus d. Y is equal to m is minus 7, x minus d is 3. Y is equal to minus 7x plus 21. Therefore, the equation is 7x plus y is equal to 21. Question 9. Find angles between the lines root 3x plus y is equal to 1 and x plus root 3y is equal to 1. We will find the slopes of these lines. We will take the slope of the first line as m1. The formula is minus a divided by b minus a is the coefficient of x, which is root 3, divided by coefficient of y is 1. Here the slope is minus root 3. Let us find the slope of the second line. We will take it as m2 minus a. The coefficient of x is 1, coefficient of y is root 3. And we have to find the angle between these two lines. The formula is tan theta is equal to absolute value of m2 minus m1 divided by 1 plus m1 m2. Absolute value of minus 1 divided by root 3, minus of minus root 3 will become plus root 3 divided by 1 plus minus root 3 times minus 1 by root 3 will become plus 1. We will take LCM in the numerator. We will get minus 1 plus 3 divided by 2 times root 3, which is 2 divided by 2 root 3. The answer is 1 by root 3. Tan theta is 1 by root 3. Therefore, theta is 30 degrees. If two lines intersect each other, there are two angles formed. One is an acute angle, the other one is an obtuse angle, which is 180 minus theta. These two angles are supplementary. So, if the acute angle is 30 degrees, the obtuse angle is 180 minus 30, 150 degrees. Therefore, the angles are 30 degrees and 150 degrees. Question number 10. The line through the points H3 and 4,1 intersects the line 7x minus 9y minus 19 equal to 0 at right angle. Find the value of h. We will first get the slope of this line through these 2 points. m1 is equal to y2 minus y1 divided by x2 minus x1 is the formula to find the slope when we know 2 points. 1 minus 3 divided by 4 minus h, which is minus 2 divided by 4 minus h. We will find the slope of this line. We will take it as m2. The formula is minus a by b because it is in general form. Minus a is the coefficient of x and b is the coefficient of y, which is 7 over 9. Now, these two lines are perpendicular. The perpendicularity condition is m1, m2 is minus 1. Minus 2 divided by 4 minus h times 7 divided by 9 is minus 1. We will cancel the negative signs. 14 is equal to 36 minus 9h. 9h is 36 minus 14, which is 22. Therefore, the value of h is 22 over 9. Question 11. Prove that the line through the point x1, y1 and parallel to the line ax plus by plus c equal to 0 is a times x minus x1 plus b times y minus y1 equal to 0. We will write the equation of parallel line. We know that only the constant terms will be different. Ax plus by plus c1 equal to 0. Now, this line passes through x1, y1. Let us substitute this point. ax1 plus by1 plus c1 is 0. Therefore, c1 value is minus ax1 minus by1. We will take this as equation 1. We will substitute c1 in equation 1. Ax plus by plus c1 is minus ax1 minus by1 equal to 0. Let us rearrange the terms. A is common. We get x minus x1 plus b times y minus y1 equal to 0. This is the equation of the straight line. Question 12. Two lines passing through the point 2, 3 intersects each other at an angle of 60 degrees. If the slope of one line is 2, find the equation of the other line. We know tan theta formula, angle between two lines. Absolute value of m2 minus m1 divided by 1 plus m1 m2. We will take the slope of the second line as m2. Tan 60 is equal to absolute value of m2 minus 2 divided by 1 plus 2 times m2. And tan 60 value is root 3. m2 minus 2 divided by 1 plus 2 m2. To remove the absolute value sign, we will write plus or minus on the left hand side. We have two equations to solve. Plus root 3 equal to m2 minus 2 divided by 1 plus 2 m2. And the other equation is minus root 3 is equal to m2 minus 2 divided by 1 plus 2 m2. Cross multiply. Root 3 plus 2 root 3 m2 is m2 minus 2. 2 root 3 minus 1 m2 is minus 2 minus root 3. Therefore, m2 from this case is minus of 2 plus root 3 divided by 2 root 3 minus 1. Let us solve the second equation. Cross multiply. Minus root 3 minus 2 root 3 m2 is m2 minus 2. m2 times 2 root 3 plus 1 is 2 minus root 3. Therefore, m2 is 2 minus root 3 divided by 2 root 3 plus 1. Now, the first answer, the line passes through 2, 3 and the slope is minus of 2 plus root 3 divided by 2 root 3 minus 1. We will use point slope form. Y minus y0 is equal to m times x minus x0. Y minus 3 is equal to m is minus of 2 plus root 3 divided by 2 root 3 minus 1 times x minus 2. We will cross multiply. 2 root 3 minus 1 y minus 6 root 3 plus 3 is equal to minus 2 plus root 3 times x, and minus into minus is plus 4 plus 2 root 3. Bring that x term to this side. 2 plus root 3 times x plus 2 root 3 minus 1 y is equal to 2 root 3 plus 6 root 3 will be 8 root 3 and 4 minus 3 is 1. Now we will write the second answer. It passes through the point 2, 3, but the slope here is 2 minus root 3 divided by 2 root 3 plus 1. We will use point slope form. Y minus 3 is equal to, slope is 2 minus root 3 divided by 2 root 3 plus 1 times x minus 2. Cross multiply. 2 root 3 plus 1 into y minus 6 root 3 minus 3 equal to 2 minus root 3 times x minus 4 plus 2 root 3. Bring this x term to this side. Minus of 2 minus root 3 can be written as root 3 minus 2 x plus y term is 2 root 3 plus 1 y equal to 2 root 3 plus 6 root 3 is 8 root 3 minus 4 plus 3 is minus 1. This is the second answer. Question number 13. Find the equation of the right bisector of the line segment joining the points 3, 4 and minus 1, 2. The points are 3, 4 and minus 1, 2. We have to find the equation of the right bisector. Perpendicular bisector of this line. This is 90 degrees and this is the midpoint of AB line segment. We will name them as A and B. We will find midpoint of the line segment AB, which is M. Midpoint formula is x1 plus x2 by 2 and y1 plus y2 divided by 2. 2 by 2 is 1, 6 by 2 is 3. So M point is 1, 3. We will get the slope of AB. When 2 points are given, the slope is y2 minus y1 divided by x2 minus x1. It is 2 minus 4 divided by minus 1 minus 3. Minus 2 divided by minus 4, which is half. Therefore, slope of the perpendicular line L is negative of its reciprocal using the formula m1 m2 equal to minus 1. Now we know one point on the line L and the slope of the line L. We will use point slope form. Y minus y0 is equal to m into x minus x0. Y minus 3 is equal to minus 2 times x minus 1 minus 2x plus 2. Therefore, the equation of the line is 2x plus y equal to 5. Question number 14. Find the coordinates of the foot of the perpendicular from the point minus 1, 3 to the line 3x minus 4y minus 16 equal to 0. The line equation is 3x minus 4y minus 16 equal to 0. We have to find the foot of the perpendicular. We will take the given point as P and Q is the foot of the perpendicular. Slope of this given line is minus a divided by b minus coefficient of x is 3, coefficient of y is minus 4, which is 3 by 4. Therefore, slope of PQ will be negative of its reciprocal because it is a perpendicular line. M1, M2 is minus 1. And P point is minus 1, 3. We can write the equation of line PQ using point slope form. Y minus 3 equal to minus 4 divided by 3 times x minus of minus 1, which is plus 1. 3y minus 9 is minus 4x minus 4. 4x plus 3y is 5. This is equation of PQ. And we will take the given line equation as 1. By solving 1 and 2, we will get Q point. That is the point of intersection of these two lines. We will multiply the first equation by 4. 12x minus 16y is equal to 64. And we will multiply the second equation by 3. 12x plus 9y is equal to 15. Let us change the sign. These two will get cancelled. minus 25y is equal to 49. Therefore, the y coordinate of the point is 49 divided by minus 25. We have to find the x coordinate. We can substitute in any one of these two equations. We will use the second one. 4x plus 3 times minus 49 over 25 is equal to 5. 4x is equal to 5 plus 147 divided by 25. LCM is 25. 125 plus 147. 272 over 25. Therefore, x is 272 divided by 4 times 25. We get 68 divided by 25. This is the x coordinate of that Q point. Therefore, the foot of the perpendicular is Q point. The x coordinate is 68 over 25 and the y coordinate is minus 49 over 25. Question number 15. The perpendicular from the origin to the line y is equal to mx plus c meets it at the point minus 1, 2. Find the values of m and c. Let this be the line L, which is y is equal to mx plus c. This is a perpendicular and foot of the perpendicular is minus 1, 2. We have to find the values of m and c. We will take this point as P. Slope of OP is equal to y2 minus y1 divided by x2 minus x1. O is 0, 0. 2 minus 0 divided by minus 1 minus 0, which is minus 2. Therefore, slope of line L will be negative of its reciprocal. So, it becomes plus half. Because of the formula, m1, m2 is minus 1. The given line equation is y is equal to mx plus c, from which the slope is m. And we got the slope of this line as half. Therefore, m value is half. Now, the point minus 1, 2 lies on the given line y equal to mx plus c. Y is equal to m value is half. Now, we will substitute for x and y. 2 is equal to half into minus 1 plus c. We have substituted the point minus 1, 2, from which we can find the value of c. Therefore, C answer is 5 by 2 and M answer is half. Or we may find the equation of that line using point slope form and we can find M and C. Question number 16. If P and Q are the lengths of perpendiculars from the origin to the lines x cos theta minus y sin theta equal to k cos 2 theta and x secant theta plus y cosecant theta is equal to k respectively, prove that p square plus 4q square is equal to k square. We know the distance of a line from the origin formula. Absolute value of c divided by root of a square plus b square. We will calculate the distance of origin from the first line. Let it be d1 and here c term is k cos 2 theta. You may write minus k cos 2 theta or k cos 2 theta, because of absolute value sign it does not matter. Divided by root of coefficient of x is cos theta. So we get cos square theta plus coefficient of y is minus sin theta the whole square is sin square theta, and this distance is given as p. Now we will find the distance of the origin from the second line. We will take it as d2. Absolute value of c here is k divided by square root of coefficient of x is secant theta. So secant square theta and coefficient of y is cosecant theta. We get cosecant square theta, and this distance is q. From this first one we get absolute value of k cos 2 theta is equal to p. The denominator becomes 1. Let us simplify this d2. Absolute value of k divided by secant square is 1 by cos square theta and cosecant square is 1 by sin square theta. We will take LCM. Cos square theta times sin square theta is the LCM. We get sin square theta plus cos square theta. Write the reciprocal of the denominator, absolute value of k, and square root of cos square theta sin square theta should be written as a positive quantity. We will write absolute value of cos theta sin theta. This is our first equation. This is the second equation. Now we will find p square plus 4q square. It is absolute value of k cos 2 theta the whole square plus 4 times k cos theta sin theta the whole square. Because of squaring, absolute value sign can be removed. We get k square cos square 2 theta plus 4 k square cos square theta sin square theta. K square is common. We get cos square 2 theta plus, I can write this as 2 cos theta sin theta the whole square, which is k square times cos square 2 theta plus 2 cos theta sin theta is sin 2 theta. Therefore, it is sin square 2 theta. This becomes 1. Therefore, the answer is k square. That's what we have to prove. P square plus 4q square is equal to k square. Question 17. In the triangle ABC with vertices A 2, 3, B 4, -1 and C 1, 2, find the equation and length of altitude from vertex A. A is 2, 3, B is 4, -1 and C is 1, 2. Let us draw an altitude AL to BC. AL is perpendicular to BC. We will get the slope of BC. We know 2 points, so we will use y2 minus y1 divided by x2 minus x1. 2 minus of -1 divided by 1 minus 4, which is 3 divided by -3 minus 1, from which we can write the slope of AL, because AL is perpendicular to BC. Change the sign and write the reciprocal. And we know one point A on this line. We will use point slope form to find the equation of AL. Y minus 3 is equal to slope of AL is 1, x minus 2. So y is equal to x plus 1, or y minus x is equal to 1. This is the equation of AL. we will find the equation of BC. Y minus y0 equal to m into x minus x0. Y minus, I will use B point, minus of minus 1 is plus 1. Slope of BC is minus 1, we have already calculated. Minus 1 times x minus 4. Y plus 1 is equal to minus x plus 4. Equation of BC is y plus x is equal to 3. And A point is 2, 3. So the length of the altitude AL is the distance of this line BC from the point A. And the formula is absolute value of AX1 plus BY1 plus C divided by root of A square plus B square. Substitute this point in this equation, that is the numerator. Absolute value of y is 3, x is 2, take the constant term to the left hand side, minus 3, divided by root of coefficient of x is 1, coefficient of y is also 1. We get 2 divided by root 2, which is root 2 units. This is the length of the altitude. We found the equation of the altitude and the length of the altitude. Question number 18. If P is the length of the perpendicular from the origin to the line whose intercepts on the axes are A and B, then show that 1 by P square is equal to 1 by A square plus 1 by B square. The line makes intercepts A and B on x and y axis. So we will use intercept form of a line, which is x by A plus y by B is equal to 1. X by A plus y by B minus 1 equal to 0. And let us find the distance of this line from the origin. The formula is absolute value of C divided by root of A square plus B square, which is equal to, in this equation the constant term is minus 1. We can change the equation to general form and use it, or we can keep it in this form, divided by root of A is the coefficient of x, which is 1 by A, the whole square. Coefficient of y is 1 by B, so we get 1 by B the whole square. And this distance is given as P. Absolute value of minus 1 is 1, divided by root of 1 by A square plus 1 by B square is equal to P. We will square both sides. We get 1 by A square plus 1 by B square is equal to P square. Let us cross multiply. 1 by P square is 1 by A square plus 1 by B square. And this is the result to be proved.